Okay, so I'm going to make a video here showing some work I've done on I guess it's really a pipeline, but what I'm doing here is trying to bring in some vendor data into a model and then do some work with it into an ADT model. So for quick study here, I have two Cameo models. One here is a volume model from a vendor, and this would be vendor. I think I call it vendor A volume model. They just have a couple of dimensions. This could be CG and moment of inertia and things like that. But in this case, I just did some basic length, width, and height. And then what I want to do is I want to rip these out of here and then put them somewhere else into our model, which would be an ADT model. So I have an example ADT model, which here is essentially just a system model that has a volume parameter. And let me update this real quick. These are going to update from my last run. And so what we'll do is we rip the parameters out of the other model and we stuff them in here. And then I do a couple different ways of analyzing this. One of them is internal, one of them is partially internal, and then one of them is external. And there's a CAD model involved, and we'll get through this. This is going to probably be a long video, probably 20 minutes, so bear with me as I go through it. You can see those updated. So what I do now is read that in, and I can also, there's also a parametric model here to calculate the volume internally. Here you could do that, but we're not going to do this. It's not really the way I wanted to do it. In this case, I have in this system model, let me go back to the system model, I have a activity diagram so that when I execute the systems model, it will run this activity diagram here of opaque actions. And so essentially what I'm doing is I create a volume model object, which is this here. I grab it and turn it into my own new object that I'm going to analyze separately. And from this here, I kind of extract the length, width, and height from it. You can see how I do it. I go ALH. These are, gosh, I can't remember what ALH stands for. It's something language helpers. I can't remember what A stands for, but it's a language helper essentially to help you dig around the model and get input and outputs from other attributes and things like that. So calculate a volume, and then I set the value of the self, which is the system, because that's what I'm going to run. Set the volume to whatever that volume is calculated. I add 0.001 to it just so the difference between the CAD volume, and I'll show you where I get the CAD volume from. I do that remotely, externally with a tool in Jupyter Lab as part of a workflow or a pipeline. And put it back in there. I also have an output here, which is that actual calculated volume. It goes nowhere here, but I could actually stuff it into maybe a parameter node and then export it back to some external simulation. I also have a simulation set up here, so simconfig. This is what we can call remotely. So I can actually call this simconfig called calculated volume with a remote command, which will then run this up on the remote teamwork cloud server. And then in this case, it's not returning any values because I'm running Teamwork Cloud 19 Service Pack 3, and there's some errors. It doesn't save things in certain places, and it's not following the right rules. But I also can export this data to a CSV file. In my case now, the CSV file is coming to my local machine, but really what will happen is this will go to, if we use this method, to a remote machine, and then that remote machine is mapped to a particular centralized data set or data server or EFS, like a file server, and then we'll know where it goes by name. So anyway, I can call this remotely, and that's kind of important. So now let's go back into what I'm doing here. So I have working in Jupyter Lab, and I'm communicating with the Teamwork Cloud server via Jupyter Lab. So one of the things I do here is I have a tool called Elyra, which is a pipeline tool, and I created a pipeline. And you can see this pipeline tool here it's pretty neat. It's very simple to use. You just drag your notebooks onto the pipeline, and you can then connect them up and run them. So when I run this, it'll run through this whole set of these are essentially the same files you saw before where I'm pulling information from the Teamwork Cloud service. So I also hard-coded the UUIDs of the models in here so we don't have to go look for them. That would probably be better served being done by or through some sort of application tool or some sort of intermediary tool that we model, extract, those values from. So anyway, let me walk you through the pipeline real quick. First thing it does when it kicks it off is pull vendor data. So it actually goes in and pulls the vendor data from the model, which is that length, width, and height. It writes it to a file right here called vendor a.json, and you can see it here. There's length, height, width, date, time. We're not using that now, but it writes it to this little local file. And so then I update a CAD model, and this is neat because what I can do is I can review a CAD model locally. I also push the CAD model to GitHub, so we can store the CAD model separately. But I also calculate in this CAD model, I calculate the volume of the CAD model. So it tells me the volume. I calculate it here. I take that volume, I stuff it back up in the model as a CAD model calculated volume. Not, I'm just having some fun here. I don't know exactly what the right thing to do is. I'm just taking a volume as a fun test. But, of course, we'll be probably looking at CGs and the mill standard requirements, all kinds of fun stuff like that. Then, after I calculate the CAD volume, I go ahead and I push the values back up into the model. This is the ADT model. So essentially imagine taking the data out of a vendor's model, doing some work on it, maybe doing some testing, and then pushing it back into the vendor's model, or to the ADT's model, and then performing these analyses, updating our internal analyses in the ADT model. Maybe we have some attached constraints through MathCAD. Maybe we have some other services we run. Just things like that. These can happen right here. This can kick it off and control. And you can see this is easy to control. We can grow. This could grow to 20, 30 pieces, 30 steps. Here I go ahead and execute that model on the server, and you can see it's not a very complex call. I actually just change the Java home and say, hey, simulate which project, which simulation, and where's it at, and it runs it, and it'll return information. So you can see it actually runs it. It's not returning the output here. It should show it here, but it's writing it to a log file. I just don't have access to this Teamwork Cloud server because it's run by somebody else in the group. I don't know who it is. And then finally, I store some plots. So here's a plot of the history of the vendor A volume. So it's like you can keep track of the history of the volume over time and things like that. So I also did a couple more things. So I added a monitor command. So this monitor will run. I'll start it up now, and it'll run, and it will monitor the model. It'll actually monitor this vendor A data. Every 30 seconds, it goes out and checks the model up on TWC. If the TWC model changes, then it updates this vendor A file, and then once it sees that, it kicks off this pipeline and reruns everything. So then I have these dashboards. So the dashboards are really nice. You can monitor everything live, see historical data, and plot some fun stuff. So let me go ahead and get this running now, and I'll show you what it looks like. So, all right, so I'll do a start dot that. What this will do, it'll start the couple things. So it starts these dashboards. So you'll see that there's a dashboard here with all the historical data from my last runs, and we'll go ahead and make a change here, and you'll see it show up. I also have a neat tool where I can look at the CAD file live. So you can, this could be complex CAD models, but right now it's just a block. But it's live to look at, and that's kind of fun. So lastly, what's going on here is you can see this is a tool that's running in a loop. And right now, give it a second. I'll chop this, but it's running the notebook and retrieving the data from TWC. It'll write it and then check and see if it changed from the last time. If it does, then it kicks off the workflow and will update our model, the ADT model, and its analyses associated with that and the dashboards automatically. So it's pretty neat. All right, so running, see what it's doing. Let me go ahead and change something here. So let me lock it, and we'll make something like the height here real high. Oh, wrong one. 14. Close, save it, and commit. All right, so it's going to commit that, and then it's going to, if it sees that change, it'll go ahead and kick off the workflow. I don't know how much time we had left. We have to wait another 30 seconds. All right. No, so I have to wait another 30 seconds. It's going to run the notebook. And again, I'll chop this out. Something fun too is that I actually send this data to, oh, that's annoying. Avian, yeah. So I send the model here too for fun. Teamwork Cloud Interactions, and then in Models CAD. So you can look at it here too. So there it is live. That's the latest model. All right, so it does. It saw that it changed. Now it's kicking off that pipeline. The pipeline is, you know, this pipeline we're talking about right here. So it's running this. It's going to push the new model out to the CAD file or out to GitHub. It's going to push the data back into the R model, into the vendor A part of our ADT model. It's also going to execute all the analyses that you call. So I could actually call multiple analyses from multiple models and run all kinds of stuff here. And then it's going to store this plot data so I can update these volume reports. So if we go back and watch it, it takes a while for this to run. This is again another 2 or 3 minute run. So remember the pipeline, what it's doing is it's going out to Teamwork Cloud, extracting, and I actually hard coded the UUIDs of those in there, so you can do it a couple different ways. Look by name or look by, we talked about doing it by fully qualified name, which is probably the best way to do this, but I'll be working on that next. So what I'm going to do is build an actual analysis tool template, which we can then define what we want to do from a Cameo model, and then go grab that from Teamwork Cloud first, then run all this stuff without having to hard code anything. And this tool could be something on AWS, or it could be Jenkins, or it could be, I don't know, there are many ways of doing this, you know, tons of ways to skin a cat, but pretty easy. This is a very simple script. It's literally 20 lines of code, and this could just run forever. Of course, it'll grow significantly when we add error checking and, you know, testing of the script. But right now it's just a few lines. I think it's, if we look, yeah, what is it, 40 lines, really about 30 minus all the spaces. So not much to it. The other neat thing to think about here is that instead of using this tool here, we could turn it into a internal workflow in Cameo. So, you know, I've been kind of griping about that for a while now. We can build something like this in Cameo to do this with these opaque actions. I can go out and do all kinds of fun stuff. So looks like it's done. You can see it's the model wants to be up. Oh, it did update the model first, didn't it? So let me update from the server, and you should see these change. I think that was 14 for the height. All right, so it did update to 14. This should go ahead and finish now. All right, so it finished. Now it goes back into the loop, waiting for something else to change in our other model. If we were to go back here and change one of these values, it would notice that the model changed, and it would kick off that workflow again. But the neat part here now is that we have localized data that's monitoring what's going on. So if we go to the volume report, I can hit refresh, and this is probably going to go huge now. You'll see, yeah, the volume went way up, but we moved the height of the part to 14. We have a history here, and we also have a data set history too. You can update the CAD model, so this should grow really large, and look at it here remotely through a, you know, some sort of demo page. There it is. And then the fun part is this is up on Bitbucket also, or this is GitHub, sorry. So there it is. That's the latest version. So this can be GitLab, store the data there, you know, the models there, and they'll be live for people to look at. Of course, when we have a PLM system, that may not be necessary, but it's pretty easy to do this in GitLab or GitHub and make it, you know, accessible to people quickly and easily. So anyway, that's the workflow now. It's automated, fully automated, running, waiting for me to change the model. And let's see if it still. Oh, it ran the pipeline again. Shouldn't have done that, but it's, you know, just going to keep running and watching for me to make some changes to this thing. So again, real nice tool. This is called Elyra. You can build some really complex workflows. They're easy to kick off from command line calls. So essentially you just say Elyra run, and then you tell it what pipeline is, and it'll run this pipeline for you. We can put these up on EC2 servers easily, and then really build this out into a really complex system. Or we're going to want to. It's not going to be one way or the other. There's going to be some hybrid stuff going on. So there may be some room for Elyra. There may be some room for Jenkins. There may be some room for some other workflow tools. There's probably some room to do some more complex, some very complex workflows here in Cameo, and actually execute those in the workflow or the digital thread too. So that's it for now, guys. I'll go chop this up and send it out. I think the next step here, though, is to go ahead and build some sort of ICD and some sort of analysis tool templates that allow me to define what I want to come out of the model from the vendors and into the model of the ADT team via a intermediate model, which essentially maps inputs and outputs and then has these calls to call the particular workflows to build those out. So, all right, that's it now for now. Thanks.